Absolute value inequalities. So there's a couple of things. So just like before, if you see a greater than or greater than or equal to, those are still ors. Okay? Less than, equal to are still going to be ands. All right, so just like we've done before, I'm just going to go ahead and get to it. Just a quick little reminder about, remember when we were solving absolute value equations? You had to get the absolute value by itself, and then you did this. Here, let me just give you a quick little. So this was absolute value equations. Let's just say we had x minus 1 equals 2. You broke it up and you made this x minus 1 equals 2. And over here you make this x minus 1. And then remember you did the opposite of 2, which is negative 2. And then we would add 1. That was a solution. Add 1. That was the solution. So that was equations. So now we're going to throw in inequalities. And this is what they look like. So the absolute value of b plus 2 is less than or equal to 3. All right, remember, I see this less than is less and, so it's an and inequality. Okay, I've got to break it up. So I make this b plus 2 is less than or equal to 3. And then b plus 2, and I know this has to be negative 3, but if I'm going to make that a negative, I got to flip my inequality. Okay? Now I can go ahead and solve each side. So I subtract 2. This is b is less than or equal to 1. Over here I subtract 2. b is greater than or equal to negative 5. Go ahead and do your number line. Let's just pretend like this is 1 and this is negative 5. All right, so 1 going to the left, and then negative 5, oops, this is supposed to be a closed circle, huh? All right, and then negative 5, closed circle, going to the right. This is an and, which means intersection, so I need to go ahead and redo my graph. So my intersection are all the numbers in between negative 5 and 1. If I wanted to write that as set notation or as interval notation, I would go to negative 5 bracket 1 bracket. Okay, and then here's my solutions, and I can go ahead and make that into set notation as well. So I would say b for all b's less than or equal to 1, and b is greater than or equal to negative 5. Okay, here's example number 2, or 3 technically. Let's do this one over here. Absolute value of 2d minus 1 is greater than or equal to 4. Okay, so I look at that inequality. It's a greater, so this is going to be an or, and I go ahead and I break them up. So this is 2d minus 1 is greater than or equal to 4. This is 2d minus 1. I make this negative 4, and I flip the inequality. All right, so I add 1. 2d is greater than or equal to 5. Divide by 2. D is greater than or equal to 5 halves. Now, for the people that are like, wait, what is 5 halves? If you put that in your calculator, it's 2.5, which is in between 2 and 3. All right, over here, I add 1. Negative 4 plus 1 is a negative 3. Divide by 2. So D is less than or equal to negative 3 halves. Put that one in your calculator, it's negative 1.5. All right, so this is my solution. Actually, let me put this up here. So my solution is this, right? Let's go ahead and graph it. It's ors, so they should be going opposite ways, hopefully. Let's do 0, 1, 2, 3, negative 1, negative 2. All right, let's start with the 5 halves. So 5 halves is 2.5, which is in between 2 and 3. So it's a closed circle going to the right. And then negative 3 halves is negative 1.5, which is in between negative 1 and negative 2. Closed circle going to the left. So that's my graph. My interval notation would be negative infinity to negative 3 halves union, oops, no, bracket because it's a closed circle. Okay, this is another closed circle, so bracket, 5 halves, okay, comma, infinity, parenthesis. There's my interval notation, and then finally my set notation would be D for all D's greater than or equal to 5 halves, or D is less than or equal to negative 3 halves. Okay, one more. Example 4. The absolute value of 2x plus 4 is greater than or equal to negative 4. All right, so I look at the inequality. It's a greater or equal, so greater, this is an or inequality. I go ahead and break them up. This is 2x plus 4 is greater than or equal to negative 4. This is 2x plus 4. The opposite of a negative 4 is a positive 4, and then I flip my inequality. And let's go ahead and solve. Subtract 4 and divide by 2. Over here, we subtract 4 and divide by 2. All right, so those are my two solutions. Once again, these were ORs, so that's my solution. Let's go ahead and set up our graph. I go to negative 4. It's a closed circle going to the right. I go to 0. It's a closed circle going to the left. This is an OR, so either or works. So actually, I have to redo my line, and the answer, let's do a rainbow, is all real numbers. So that entire thing should be shaded. So actually, this is not my solution, which is why you should always graph. My solution is all real numbers. That is my solution. All right, and then for interval notation, we got all negative numbers and all positive numbers. And then I would just say, let's see, what was our variable? It was an x. X for all x, all real numbers. Okay? All right, here are your practice problems. There are 6 of them. Make sure that you solve, graph, give interval, and set notation. Okay,